Welcome to another pre-calculus video. In this one, we're going to wrap up section 6-2, the law of cosines. We will do an example and practice problem on a real-life type problem, and then we'll do an example and a practice problem on Heron's area formula. It's a new way to find area of a triangle based on the law of cosines. Remember, when we're doing these applied problems, we don't have to solve the whole triangle. We just need to find usually one critical piece. So let's see what's going on in example 3. We got a pitcher's mound on a woman's softball field. It's 43 feet from home plate. That's right here. I have it labeled as 43. The distance between any two consecutive bases is 60 feet, so that's our 60 right here. The pitcher's mound is not halfway between home plate and second. And our question is, how far is the pitcher's mound from first base? That's right here, and I have that labeled as H. So we do have two sides and the included angle in between. And the thing we want to find is right across from that angle. So this is perfect for the law of cosines. So I'm going to write it like this. We're using h squared equals. Now, our law of cosines formula, we're going to have a side squared plus another side squared minus 2 side cos of, that's an ugly S. Let me fix it. Cos of our angle. There we go. And I'm going to slide this background picture out of the way, and now we just have our triangle stripped down to its bare bones. So the first thing we put in here and square are the sides. That would be 43 and 60. And those same numbers are repeated here, 43 and 60. And then we have our angle cos of 45. Again, always be cautious. We have to subtract this stuff as a quantity. If I'm doing this on my small TI-30 calculator, I start here. I would do 45, hit the cos key after making sure I'm in degrees, times 60, times 43, times 2, and then I would change the sign by hitting the negative key. And then I'm going to add 60 squared, and I'm going to add 43 squared. And what that's going to get me here is h squared equals 1800.33. And then I hit the square root key, and I'm going to get h, that distance that we're looking for, is about 42.43 feet. Okay, so there's our applied example. For the practice problem, let's look at this one. Checkpoint here. In a softball game, the batter hits the ball dead center field, distance of 240 from home plate. Here, I just stole this picture from the previous example. The 240 feet, when it says dead center field, it went straight off home plate. So this red line is our 240 feet. The center fielder then throws the ball to third base. That would be the blue line. The center fielder caught it here, throws it to third base. That's the blue line. And that's what we're trying to find. How far is that infielder from third base? Once again, the distance between any two consecutive bases is 60 feet. So I'm going to move this background picture out of the way. And I forgot to mention here, in our last example, this was 45 degrees here, so that's also going to be true on this side. So there's our angle. So good spot to pause the video, try this practice problem, and see if you get the same answer as me. Okay, I'm going to call this missing side here just A, because why not? So our law of cos formula says we're going to have a squared equals. We're going to have our two included sides here, quantity squareds, and then we're going to have a minus 2 side times cos of our angle. So back in our picture here, our angle again is 45 degrees, so I'm going to put 45 in there. And then our two sides are 60 and 240. So I'm going to go 60 and then 240. And then after the minus and the 2, another 60 and another 240. And if the calculator button pushing went well, you should have got a squared equals 40,835.3. And then we hit the square root button, and we get a is about 202.3 0.1, come on decimal, it's not working, 0.1 feet. All right. And now let's look at Heron's area formula. The law of cosines can be used to establish a formula for the area of a triangle. This formula is called Heron's area formula after the Greek mathematician Heron back in 10 to 75 AD. Let's check out his formula. First, let's go to the bottom here. We've got this variable defined S. S is half the perimeter of the triangle. Half the perimeter. So we've got in our numerator a plus b plus c, that's all three sides added up, and then we divide that by 2. So that is this new thing called S, and now I'm going to recreate Heron's formula down here. I'm going to drop a big radical, and then under that radical I've got S, and then we're going to multiply that by S minus side A, and S minus side B, and S minus side C. And it's as simple as that. We find S, and we already have our three sides A, B, C. We plug them into formula, and we get the area of our triangle. So here, use Heron's formula to find the area of a triangle with these side lengths. I'm not even going to draw a triangle. We've got our A, B's, and C's. So first, let's find S. S means we're going to add 43, 53, and 72 together. And we're going to cut that number in half. If we add up our numerator, we get 168, and we divide that by 2, and then that is 84. So I'm just going to scribble it up here for safekeeping. S is equal to 84. So our area is going to equal. So first, I'm going to put the 84 under here, and then I'm going to need 3 sets of parentheses. Each set of parentheses will start with an 84, but then we're going to subtract our side length. So here I'm going to do minus side A, and then here minus side B, and then minus side C. So we've still got our leading S out here, that's 84. But when we subtract these, we're going to get a 41. And then the next one gives us a 31. And then 84 minus 72 is 12. And then I'm going to just multiply all those together. And I'm going to hit the square root key. And I'm going to get approximately 1,131.89. Our units here are meters. And we found area, so meters squared. And there is Heron's area formula. And now, of course, I'm going to leave you with a practice problem. So here it is. Set it up and solve it, and then fire up the video and see if you got the same answer as me. Okay, so if all went well, you should have added up the three sides and got 22. And we're going to divide that by 2. So our S value is 11. And then under our radical, we should have 11. And then we're going to multiply that by 3 things. We're going to have 11 minus 5. That's 6. And then we're going to have 11 minus 9. That's 2. And then we're going to have 11 minus 8. That's 3. So I punch them in my calculator. 11 times 6 times 2 times 3, and I hit the square root key, and you should get approximately 19.9. Here our units were inches, so that's going to be inches squared. Alrighty, when we get together in class, we'll review this, do some practice problems, and we can do the homework.